To answer this data sufficiency question, we'll consider each statement separately first and then together if needed. We're told that the set E contains 5 distinct positive integers, x, 4, 2, 6, and y. Is the mean of set E greater than its median? So we need to decide whether we have enough information to concretely answer the question. Let's consider statement 1. Since all 5 integers in set E must be distinct and positive, there are a limited number of values for x and y, where the largest integer in E is 6. So let's go ahead and let's list those possibilities. One of the possibilities would be we have the set 1, 2, 3, 4, and 6. Next, we could have the set 1, 2, 4, 5, and 6. And last, we could have the set 2, 3, 4, 5, and 6. For each respective possibility, we have that the mean is greater than the median. So that in that case, our answer to our question would be yes. In this set, we have that the mean is less than the median. So in this case, our answer to the question would be no. And lastly, we have that they're actually equal. So in this set, the answer to the question would also be no. Now, since we have a mix of answers, we can't definitively answer the question. So that means that this statement alone is not sufficient. We can actually eliminate answer choice A and D and move on to statement 2. Moving on to statement 2, we're told that the smallest integer in set E is 2. So we actually have infinite number of possibilities that we can just pick a few test cases to see if we can arrive at a definitive answer for all sets. Let's choose the smallest possible set that we could have. If E has the smallest numbers, would be 2, 3, 4, 5, and 6. And in this case, we saw last time that the mean is equal to the median. So since the mean is equal to the median, the answer to the question would be no, that the mean is not greater than the median. But we need to consider a couple different cases, so let's consider another case. Suppose E is equal to 2, 3, 4, 5, and 100. Now in this case, our mean is definitely going to be greater than our median. So the answer to the question would be yes. The mean will be greater than the median because we're heavily weighted on the end for our larger numbers. And the median is strictly just the middlemost number, which would be 4 here. But the mean is the average of the total numbers, so we're going to be weighted a little bit higher when we find the mean. So in this case, again, we can't arrive at one single answer for all cases. So this statement alone is not sufficient, and we can eliminate answer choice B. So to continue working and narrow down our answer choices, we'll need to combine our statements. So let's go ahead and scroll down a little bit to combine our statements 1 and 2. The only set that works that satisfies both our statement 1 and our statement 2, since statement 1 we've exhausted all of the possibilities, statement 2 restrictions restrict us to this set right here. Only if E is equal to 2, 3, 4, 5, and 6 does it satisfy both statements. So when we're considering the sets that fall into the statements combined, this is the only one we have to consider. Now in this case, we saw that the mean is equal to the median. So the answer to the question would be no. And we can definitively answer the actual question. Is the mean of set E greater than its median? And the answer would be no. So these statements together actually are sufficient. We can eliminate answer choice E, and the correct answer would be answer choice C. Both statements together are sufficient, but neither statement alone is sufficient.